In this video, we are going to find natural numbers x and y such that 2 to the power of x equals 3 to the power of y plus 5. Before we move on, don't forget to give it a like, subscribe to my channel, and turn on post notifications. We can first try some small numbers for this Fenton equation. We're given that x and y are at least 1, so we start with y equals 1. When y is 1, then 2 to the power x equals 3 plus 5, which is 8. So x equals 3. When y equals 2, 2 to the power of x equals 9 plus 5, which is 14. And there is no integral solution. When y equals 3, 2 to the power of x equals 27 plus 5, which is 32. And that means x equals 5. If you keep trying, say y equals 4, 5, 6, 7, 8, then there cannot be any more solution. So for the rest, we have to prove that there is no solution when y is at least 4. But instead, I'm going to focus on the number x now. So all the solutions afterwards, x must be at least 6. From this, we can say that 2 to the power of x must be a multiple of 64. In fact, I choose to focus on x because the number that I need to consider about when we take mod will be the smallest. If I focus on y, then I have to start with y is at least 4, and then what I can deduce is 3 to the power of y will be a multiple of 81. But this is a bit harder than doing mod 64, so I'd rather focus on x. Now from this, we can put it back to the equation under mod 64. Then we can say that this part of 3 must be 59 or minus 5 mod 64. And then we can exhaust all the possibilities of powers of 3 mod 64. Here are the possible values of powers of 3 mod 64. There are 16 of them, and 59 is over here. The 11th of them of this list. So that means we know that under this periodic sequence is the 11th element. So that means all the exponents must be congruent to 11 mod 16. So we still haven't eliminated all the possibilities of y. We still have one every 16 numbers to be possible solutions. But we can make use of this and make some other further deductions on 3 to the power y. To do this, we can consider mod 17. The reason that I consider mod 17 is that I'm certain that 3 to the power of y, I should say 3 to the power 16 must be congruent to 1 mod 17, and this is due to Fermat's little theorem, which says that for any prime p, if the base is not divisible by the prime, then the base to the power p minus 1 is congruent to 1 mod p. So I'm going to make use of this and do mod 17. So is congruent to 3 to the power 11 mod 17. And to calculate this in a quicker way, we can start with 3 to the power powers of 2. So 3 to the power 1 is 3. 3 to the power of 2 is 9. Then we can keep squaring. 3 to the power 4 is 9 squared, 81. So that's 13. And 3 to the power of 8 is 13 squared again, 169. So that's minus 1. Or for 3 to the power of 3, it's just 27 mod 17. Okay, so minus 27 mod 17 will be just 7. And that means 3 to the power of y does not only have a fixed value under mod 64, but it also has a fixed value under mod 17. So therefore, 2 to the power of x is congruent to 7 plus 5 mod 17, and that's 12. But now we can start testing possible values of 2 to the power of x under mod 17. But that's actually pretty easy, because 16 is one of them. And that is actually just minus 1. And so for the rest is minus 2, minus 4, minus 8, and then we'll go back to 1. And even I change the negative numbers to positive, they are just 15, 13, and 9. So, and 12 is not on the list. So that means there is no solution for all numbers of x that is greater than or equal to 6. So that means the solutions above, the small numbers, are the only solutions, which are 3, 1, and 5, 3. These are the only answers. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.